Alright, so today I'll be going over a solution I found on YouTube to Leetcode 11 container with most water. Originally I did this with the brute force method, but the runtime didn't work despite going through these test cases. The runtime, it was just running too long, so I decided to search up a solution which may be easier, and I'm going to try to explain it, at least my interpretation of it. So you're given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I in 0 and I in height, or high at I. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. So basically what this problem is asking you to do is that it wants you to find the maximum area that you can find within this array, pretending that each one of these values is in turn a y value, and then you're going to use the distance between 2 points as, the distance between the indexes as your x. So in this case, we found, okay, well, my biggest you end up getting 49 because you found that, okay, well, if I'm here and I have 8 and I'm here and I have 7, if I just lower this to be 7 because we're not allowed to have slants, well then this is the maximum. I'm able to reduce the maximum area I'm able to reduce. And that's kind of something you want to note with this, is that you're trying to find I guess a maximum, and you wanted to do so by not only finding, okay, the biggest distance, but finding the biggest height. And that's kind of what this code aims to do. So you say, okay, here's your res, you set equal to 0. Then you have an L and R, L being set to 0, and your R pointer, your right pointer, being set to the length of height minus 1. So you're starting 1 at the beginning and 1 at the end. And so what you do is you say, okay, well, L is less than R, meaning that you don't want them to cross over and you don't want them to be equal to each other. You calculate the area, and then you update the area depending on whether that area was bigger than the last area, which helps you find the max. And then you say, okay, now this is the important part here, where you say, okay, if the height at L is less than height at R, then L plus 1, and in either the case where they're equal or the height at R is greater, R minus 1, so that way it continues in this direction. So the reason why this is important is because we want to think, like, for example, in this case, when we start here at 1 and we start here at 7, right? We say that, okay, well, your distance is 8, so, and you know that because your smallest because you have your smallest height value at 1, you know that you're going to use 1 as your height, so you're going to have 8 as your area. And in this case, the only way for your area to increase would be for you to find a number that's bigger than 7, right? So that way you can still make use of that really large distance while trying to find a y. X instead of distance, a really large x, while still trying to find a y that could also increase the height enough to find the maximum. And that's basically what this code does, where anytime you find a height that's less than the other height, you just increase it, so you can potentially find an even greater height that could lead to the maximum area. So that's basically what this code does.